I didn't even know that Stephen was introducing me tonight. And he said, do you remember the first time we met? And I was like, I wonder what this is. Stephen and I served on the board of trustees at Fulcrum Arts for many years, so I had the great pleasure of working with him on that. So first of all, thank you so much for your patience. We rewired this entire audio-visual system, so if you have any problems at home, you want new Sonos systems installed, we all got this covered for you. So I'm so glad that I want to thank Dan and Sarah for inviting me. I'm a longtime huge fan of Mount Wilson Observatory. And when Dan invited me, he said, you can touch upon things about Mount Wilson or not. But I've had a lot of fun trying to make a presentation that kind of shows the influence of this place on some of the projects that I've done. So I'm so glad that Dan asked how many of you have been up here. This is such a special place. And the title of my talk tonight is called A Bigger Infinity. And I hope starting here, and as you have your experience at these amazing domes, that you'll continue to think about what scale means and what the impact of scale on the universe is for you. So I'm going to kind of focus on about 4 projects tonight, and I'm going to start by just kind of telling you how I ended up being an artist that makes work about science. So I would say that over the years, I've kind of become an artist that has like a very research-based practice, and most of my work ends up sort of intervening with science, nature, and especially astronomy. So my first big experience of science was when I was 15 years old, and my parents took me to the Exploratorium. I went on field trips. It's a hands-on science museum. But for my this will say a lot about if you're in high school and your kid asks you to go to a science museum for their like birthday party. And we went through this tactile dome, and there was this like person doing a demonstration on cow eyes, and I was like, this is so cool. And they were like, here's an application. So this is my first job, was doing cow eye dissections. I mean, that's pretty cool, you guys. And laser demonstrations, and I would kind of like walk around in this orange vest and be like, do you guys want to learn about magnets? And it was like, it was the coolest way to realize that science is really just about curiosity. And it really fueled that. My father is a scientist, so I was never intimidated by science. But this experience at the Exploratorium, I always say, it kind of set the way that I think of my studio practice as being like playful, joyous, and creative, and just like trying to figure things out. And if you've ever been to the Exploratorium, it's 9,000 exhibits, and it just feels like a playground. And many museums have now built their exhibits, or even the Exploratorium exports a lot of exhibits around the world. I then went on to, like what Stephen was saying, I studied at UCLA, and I started off actually thinking that I might try to double major in astrophysics, and I took a lot of intro astronomy classes, but I was really clear then that I didn't actually want to become an astronomer. It was so bizarre and exciting. But I didn't start making work about science until I went to grad school. So I love showing these. These are kind of like silly little drawings that I don't think are very good, but they're very good in me understanding the trajectory of how I ended up where I'm at. So these are tiny little drawings on paper of wormholes. This was in my thesis show. It's 15 feet by 6 feet of a wormhole. And when I was in grad school, they have this grant, and all the grad students compete for it because it's a travel grant for one person to do something between their first and second year of grad school. And really people apply for it because it is like the ultimate bragging rights. And all of my colleagues and my peers were like, I remember one of my friends said, I wrote about going to the Tate and crying in front of the Rothkos. And I was like, I want to go to the Atacama Desert and look for black holes. And I think they thought that was so bizarre that they gave me this grant. And this was, this was like one of the coolest experiences. I spent 2.5 months in the Atacama Desert, but I was also not a photographer, and I was a painter. So I was like, what am I going to do to document this experience, and how am I gonna, take something away from it? So I started learning how to do long exposure astrophotography, and you guys have seen images like this. I love showing these. Again, I kind of love showing my first failures of things and then like how I got there. So the one on the right is one of the first rolls that I took, and you can see that I left my light meter on, so there's like a light leak. But when you think about these images that you're seeing, you can think about it tonight as well. This is like a very fundamental way of proving to yourself that the Earth is turning in space. So you take a 35mm camera, open the lens, and leave it open 4, 6, 8 hours. And what you see, you call it star trails, but it's really the Earth's movement. And when I was in the southern hemisphere, our view is different. We aim not towards the North Pole, not towards the North Star, but towards Sagittarius. And this was a grid of 9 photos that I showed in my thesis show. And then they're so-so, but I ended up, with the help of my very amazing collaborator, Adam Otke, who I see in the back, finally figuring out how to do really good long exposure astrophotography. And Adam and I took this at the Volcano House out in Newberry Springs much later. But one other kind of important aspect of my childhood is that my father is a really good surfer. And when I was 4, 5 years old, I was given a skateboard. And the way kids are forced into soccer? I wouldn't say I was forced, but I was just taken to the beach all the time. And so I became a very active skateboarder. And Stephen read a lot of very impressive lists of things, but this is probably my biggest brag in my life, is that I was in Thrasher magazine in 1992. And I can tell you, what, my students do not care that I went to Yale, but they really think that this is cool. So this is it's sort of like my astronomy in undergrad, where I just thought, this is so exciting, but I don't know if it's art. I don't know how it will end up in my life. And after I was out of grad school and I started showing with galleries, I ended up making a series of work. My first solo show in New York at DCKT Contemporary. And these paintings, this series was called The World is Bound in Secret Knots. And it was based on this all-girl skate crew that I had formed coming back from grad school, and we would take pictures of each other. I was really interested in the way that with the bodies removed, there was sort of this weightlessness, and there was some sort of dialogue in between sort of the physics of skateboarding and the weightlessness of space. And it took me about 2 years to make these paintings. This is only the first floor of 2 stories of this gallery. And this painting is, I think it's 8 feet by 12 feet. And afterwards, I really kind of reflected on what was I trying to do and what kind of conversation was I trying to have with my viewers about physics and this kind of very personal thing. And probably you're thinking, oh my gosh, an all-girl skate crew, how can I sign up, right? But it's also it also is a very personal narrative that was really important to think about representation. And actually, I went back to my early experiments in astrophotography. So one of the most exciting happy accidents about taking those photos in the Atacama Desert is that the rolls of film were in 800 or in 1600 speed. There are 36 exposures. But you can imagine that if you're taking photos that are 4 to 6 hours exposures, it could take you a long time to get through that roll of film. And so what I would do is I might take shoot over a period of 7 or 9 nights, and then I would just think, oh my gosh, I have another 20 images. I'll just burn the rest of the roll. But instead of just sort of discarding them, I started making these little doodles. So now think back to those early doodles that I showed you that were on colored paper. You can kind of see I'm drawing a wormhole. I would write my friends' names. Again, thinking, these are not art, these are nothing. But they were fun to make, and I liked putting them up in my studio. I was also aware at the time of this photograph that maybe some of you have seen or know about by Picasso, where he was in the dark and he made a drawing of a bull. And then the reason that you actually even see him is that then at the end of this, there's a flash of light and it shows it. But if they didn't do the bulb flash, then it would just be completely dark. And I love telling this story because I was out to lunch with a friend and she said, what are you gonna do later? What are you doing this weekend? And I said, I'm gonna attach a light to my body. I'm gonna break into the South Pasadena skate park. I'm gonna skate in the dark and think about those early drawings by Picasso. And as I said it out loud, I felt like I was like immediately embarrassed. Like, how could I take myself so seriously? And could this actually really be art? I'm gonna show you a quick video.
Ready?
3, 1, go!
3, 2, 1, go. It's 1 minute, 3 minutes.
So it turned out to be not such a bad idea. And this photo on the left, that is in South Pasadena. This piece on the right is in Griffith Park in Los Angeles. The piece on the right is in the one that's in the permanent collection of the Guggenheim. It was curated into an exhibition called Haunted about this idea of like showing action where there is no body. And these are a way that I think of like exploring, documenting the urban landscape. It also sort of paralleled my experience of growing up as a girl skateboarder in San Francisco, where in a weird way I was like right there during all this immense excitement of skate culture, but never completely invited in. So there is this aspect of haunting. So this was the part of the first series, and I've shot them in different places in the world. This is another photograph, one of my favorites, at the Sepulveda Dam. This was taken in 2015, and I was like thinking about the way in which we experience the LA River, which is usually from 70 miles an hour from your car, right? And the way in which a skateboarder sort of reinterprets landscape through the action and movement of the body. And a lot of these actually came from something my father would tell me every time we'd go surfing. I would be, a young kid, really eager to get in the ocean, and he would say, "Where are you going? Are you going to paddle left? Are you going to go right? Where, is there a break? Is there an undercurrent?" And when it's almost like you could imagine your trajectory coming out of you. You can like see where you would go on a wave. And that, I think, was really embodied in this series. So this is in Miami. I've shot them in Detroit. And it's been a real adventure because I don't call ahead. The idea is like you go, you figure it out as you go. But I would imagine that it's probably surprising to think of combining skateboarding with astrophotography. But I wouldn't have gotten to this series if it hadn't been for that experience in the Atacama Desert. The other series that Stephen mentioned was Deep Sky Companion. And you may have already heard, I love that so many of you are new up here. That's very cool because you are going to be looking through the telescopes and you'll be looking at these objects, the Messier catalog of deep sky objects. So Charles Messier was a French comet hunter. You could get rich and famous by discovering a comet, and he found this fuzzy object. He didn't know what it was, and so he labeled it M1. And then found another one of these super annoying objects, and he writes, "Objects to avoided when out hunting for comets." And this went on, M3, M4, there's a great band, M83, and we're gonna talk about one of the objects that made Mount Wilson very famous, which is M31, the Andromeda Galaxy. Oh, so that's the punchline. He was discovering galaxies. So he didn't know what he was looking at. He thought they were these annoying things, but they wwere galaxies. So one of the things that I love is this kind of relationship of historical materials and the study of nature. So as with the invention of photography, there's like a switch. Whether we think of people studying the natural fauna or astronomy, you had to be a draftsman. So this is M42, the Orion Nebula by Charles Messier, and then the contemporary image of Hubble. And so I love that a lot of my work you'll see that the way that I've decided to make them, whether they're paintings or I'm not going to show video tonight, but video work, installations, they're sort of driven by what the subject is. And so in this case, I started making these small drawings that are about 17 inches by 20 inches on translucent film, which is like, it's like plastic infused paper. But essentially, it's not transparent where light can go through, but light, can sort of go through. And on the left is my drawing, and then I took it into a darkroom the same way you would make a contract print and printed its photographic positive. So Messier discovered 110 of these objects, and if you really get into astronomy, and maybe the Astronomical Society of Los Angeles will give you some way to become a member, then there are these things called Messier marathons, where people try to use their telescope to see all these 110 objects. So it took me about 3 years to make this catalog. So I had 110 paintings and 110 these photographic rectangles. And I was invited to do an exhibition at the Cahill Center for Astronomy and Astrophysics at Caltech. And it was designed by Tom Main. And the interior is, if you haven't been inside, it's so extraordinary. There's not one even wall. This is also in the offices, by the way. So imagine trying your desk. I mean, it's fantastic, but a little bit hard to use in a utilitarian way. On the left there is David Ross of Friedrich and Fisher architecture firm, and he's done a lot of fantastic exhibition design with LACMA and MoCA. And when I was invited to do this, I thought, well, this is going to be a major problem because I have 110 rectangular pieces and 110 photographic rectangular works. And we would go and just experience that building. And it was David, through these conversations, that David suggested that we actually cut the pieces into these circular ocular discs. And this is the very exciting installation process and the final installation. And they did acquire it for a permanent installation, so you can go down and check it out in person. And one of the kind of beautiful surprises, even as the person who made this, is if you can almost see, you can see that, I wish I had a laser pointer, but there's what looks like a glass mirror there. When you look at it at first, it seems like a reflection. It's not. It's a window into their library. But if you walk into the library, those pieces are hung. It's very bizarre. It's like they're hung at 8 feet high. And so even just the act of looking at this piece, it goes through 4 stories of the building. And so it's very similar to this longing of astronomy, of trying to get closer to something and kind of having your expectations kind of thwarted. So you actually have to go up and down the stairs to see all the pieces. There's no one vantage point that you can see the whole installation. And this was my first real series where I was looking at historical archives and narratives. And I was started to become curious about Messier himself. And one of the things that I heard was that he sort of, oh, you're so nice, of course, ask for a laser pointer at a telescope and someone will hand you one. That's good, thank you. I mean, we have to go back, that window there. The whole building is like this. There's holes everywhere. And Tom Main actually designed this building thinking about observatories. So if you imagine a box and then taking a straw and going through it, so you just have to, the whole building, you can only see certain parts of it. It's very cool. Thank you so much. This is great. All right, so one of the things that was the most fascinating to me was that turns out that Charles Messier sort of went out of business because of a brother and sister team that they just basically built a better piece of glass and had a better telescope. And when I was thinking about the catalog itself, I was wondering who is the sister in this brother-sister team? And it was actually William Herschel. His father actually was the one who invented the cyanotype. And got me thinking, how many other women have served as assistants to their husbands, to their uncles, to their brothers in the history just of science in general, but especially in astronomy. And it led me to this, what seemed like at the time, like almost too weird to be true, which is like the story in a very quick nutshell, and I highly recommend you read The Glass Universe by Dava Sobel. She does an amazing job of actually telling the whole real story. But essentially at the turn of the century, in the late 1800s, the observatory director at Harvard receives a very big donation to start cataloging the night sky, and he realizes that he can double his staff if he pays women less than half the wages of men. And it's like a double-edged sword, because on one hand, you're like, that of course is a cringy thing to say, but on the other hand, you have all of these women who have just graduated out of 4-year colleges, and they are really excited about work, and they are like looking to be, looking to study in all the things that they have learned in their trajectories at all the female colleges on the East Coast. And so this is a series called Your Body's a Space That Sees, and the story basically starts at Harvard in 1893. And the women were doing all of the work based on these glass plates. So this is one of my favorite plates that I interacted with. You can see just the absolute incredible, like fastidious work that is done. And you've probably heard the term at this point as human computers, and this is where the origins are. And Harvard has the largest collection of photographic glass plates of the night sky in the world. There's 3 stories of these, and you can imagine, like, what is a glass plate? If you've never heard that term before, imagine, hopefully you remember a like 35 millimeter piece of film. It's nice and flexible. Well, imagine an 8x10 glass plate that then's coated in photographic light emulsion and then is mounted to the back of a telescope. And as you look at the domes tonight, there's a really cool landing at the 100-inch that actually has some of the mounting plates. You can kind of look for them. Well, I received a National Endowment of the Arts grant to collaborate with Harvard, and now with my very cool laser pointer, you can see here the curator made me this cheat sheet, and it had on the plates, whenever one of the astronomers was studying something, she would take the plate out and then make a note of when she was looking at it, what she found, and then she would, in light pencil, put her initials. So AJC, Annie Jump Cannon. And one of those women was Henrietta Swan Leavitt. And in 1912, this is one of the biggest breakthroughs in astronomy. And something like tonight, when you guys are looking, like, think about how impactful this is. When you look at a star, how do you know that it is not bright and close and small, or giant and far away? And Henrietta Swan Leavitt gave us the measure of the universe by studying something called variable stars in the small Magellanic Cloud. And so this is one of the this is one of her plates from Harvard that has her notations on it. And this is one of my very favorite plates that I looked at while I was there. It's just like the amount of stars in here is just gorgeous. So this is a small galaxy that you can actually see with your naked eye if you're in the southern hemisphere. And this was the very first piece that I made in this series was based on this nearby galaxy. And so similar to the series that I did at Cahill at Caltech, I started off, these are a lot larger. This one is 6 feet by 6 feet. This is called the Magellanic Cloud after Henrietta Swan Leavitt. And instead of using a darkroom, I was thinking, how could I actually use astronomy to make my work? And if these are about stars, could I use our own star to do that? And so this is a 6 foot by 6 foot piece, and this is its cyanotype positive. And the way that these are made is, here's my one of my longtime collaborators, Adam Otke, and I notice I have the safety mask on. We only had one, so figured it was more Adam was my student and then became, I mean, I can only make fun of you because you're here in the audience, but Adam and I have been working together for 15 years. Just, we've had so many fun adventures together doing dark skate, and when I say to him, like, I have an idea, he's always like, sit and brace himself for what is about to come. But essentially we turned my studio into a dark room. So this is us mixing up the chemistry, and then we coat a piece of watercolor paper with light sensitive emulsion. So it's like very closely mimicking the same way that those glass plates are taken. So the title of the series, Your Body is a Space That Sees, Carina Nebula, after Alta Carpenter. These ones are the other reason that I wanted to have this mediation of the sky, and that title, Your Body is a Space That Sees, is because the women were actually not allowed on the telescopes. And all the work that they did was, at that time, it was thought that women would evaporate if they were ever left out at night. We know that not to be true now, but I love that this, like that everything that they discovered was looking through these glass plates, and I imagine the universe sort of being embodied and coming to light. So here's a couple of installation shots. I'm kind of telling you the sizes, but this will give you an idea of how large they are. And it took us a really long time to figure out, you know, a blueprint or a sunprint. Hopefully you guys have all seen or made yourself with tiny little kits, and it's really easy to do that, but to figure out how to make these at large scale, they're pressed in between glass. I'm going to show you in a little bit of a process video, and perhaps maybe you've seen some of these already. There's a big installation of these at LAX. I worked with the Department of Cultural Affairs. I was interested in the way that, like, art, I think, and science, you know, how could both of those become more accessible? And when I first discovered this story, just like spending all this time in the archive, I was like, this is one of the coolest American stories I've heard. And so to figure out, to work with the Department of Cultural Affairs and bring this to like an audience that maybe wouldn't find themselves in a gallery or museum has been really impactful. And one of the things that I found in the archive, and I hope, Dan, that this is exciting to you and a surprise, but I found that I found these pictures of Annie Jump Cannon visiting Mount Wilson on a horse and staying in a cottage here in 1910. So she would have viewed through the 60-inch telescope, and this was in her personal scrapbook archive at Harvard University. And this one is called The Great Comet, after Annie Jump Cannon. I found this really like curious photograph of them that I was like immediately captivated by, and I just thought, like, imagine walking into a science lab and saying, okay, everybody outside, you're gonna hold hands, and there's no historic information as to how or why this photograph was taken. It's just sort of like lovingly referred to as the paper dolls. And it's very strange, but it's like they all look very collegial, they look happy. And when I had my catalog made, I invited different women in science. So I mentioned Davis Sobel. She was writing The Glass Universe, so we became sort of co-collaborators, her working on the actual story, me working on the visual story of it. And for each collaborator, I asked if I could make a portrait of them using the sun. And this is the installation shot of that series of portraits. And one of those people you probably know from, she wrote the movie The Zookeeper's Wife, Diane Ackerman. She wrote History of the Senses. And she was like, make my hair bigger. It was like so awesome. So for this catalog, she told me this story that when she was in graduate school, her advisor for an MFA in writing, I want to say, anybody want to take a guess? But the cool answer is it was Carl Sagan. And she published this book called The Planets in 1977 and hadn't published it since. And she lent me this poem for that book. So if you can, I'm going to read you a poem now. This is called One Jasper Night. How fast it winters in this archipelago of stars, where Earth lies at anchor, swollen with fidgeting animals and doubloon-like leaves, the scented ooze of flowers, curtsying geese, jasper bays where whales nurse their young, undersea volcanoes in a petrified seethe, whiz-kids machines, and curious herds of humans who speak, love, muse, squabble, and dream. A meteor storm tonight. On falling stars, thick as fireflies, I wish for brawny atmospheric planets small enough to form oceans and harbor life where other beings, bustling about their chores, may pause to admire the streaming milt of stars. Maybe, like us, they guide by those nomad lights. Maybe they've named our own roiling lantern. Other worlds roll gently around your suns tonight, like you, embedded in the veins of time. We bless you from our palace and thirst of days. Diane is actually working on republishing this book, and we just talked a couple weeks ago. I may be doing the cover, so it's extra circle. So one of the kind of most important objects here at Mount Wilson is the galaxy M31 of Andromeda. And so this is a painting of Perseus who's flying through the air. He's combating a sea monster. This is a Titian painting, and he's rescuing Andromeda. On the right is the drawing in Uranometria by Johann Bayer in 1603. And this was the very first book of the entire atlas of stars. On the left here is our friend Charles Messier's drawing of M31 Andromeda. And then Hubble in the middle here at Mount Wilson Observatory. And on the right, probably the most famous, if you walk away with anything tonight, you're gonna remember the VAR plate. And what you see here is that Hubble has written an N, and then he scratched it out. And that was, he first thought it was a nova, and then very excitedly, with an exclamation point, VAR. And that means variable star, which he wouldn't have known what to do with unless he had the measure of the distance from our friend Henrietta Swan Leavitt. And so, in a way, Hubble is very much in dialogue with the women who were doing their research at Harvard Observatory. And here is my painting of Andromeda after Molly O'Reilly. So the plate that I looked at Harvard was studied by Molly. The next series I want to show you about another connection that I've made at Mount Wilson was a installation called "The Sun Burns My Eyes Like Moons." It was something my daughter had said to me. She walked outside and said, the sun burns my eyes like moons. And I thought that actually is like a really interesting way of thinking about eclipses. And I had received the COLA Artist Fellowship, and it's a very cool fellowship. You're kind of invited to like be ambitious and do something bigger and cooler than you have. And this piece is 10 feet by 25 feet, and I wanted to basically make a temple to the sun in a way that was like, even if you didn't like know much about the sun, that I could fold in different experiences and studies of the sun into this piece. I had witnessed the 2017 full solar eclipse and gone up to Oregon to see that. And seeing a solar eclipse is one of those things, it's like, no matter what you have been told, like I feel like I was like, yeah, it's gonna be awesome. And it was like, it truly is what that definition of sublime is, where it is like total beauty and total terror in a way that is like, it's truly like outside of language. And the more I read about I started reading about how people described eclipses and what accounts were. And one of the coolest things that I found, that it actually at the turn of the century gave women a lot of access to astronomy, because eclipses happen all over the place. They don't necessarily happen at the top of a telescope where you usually would need, an observatory to view. And so, I looked into the founder of Mount Wilson Observatory, and this was probably one of the first times that I started thinking about Mount Wilson as like a place to draw history from. And This was the solar telescope that was built in the 150-foot solar telescope, which you see all the time from the freeway. Down on the 134, it towers above all of Los Angeles. It was completed in 1912. And on the right is the Hale Solar Laboratory. And this was the facade of it, which was built in Hale's backyard down in San Marino. And I was invited to go over to to look at it many years ago. It was probably like 10 years ago, but I was immediately struck by the facade. And it turns out that Hale was invited by the archaeologist who discovered King Tut's tomb. And Hale was a solar astronomer, but generally fascinated by the sun, and so borrowed some of the carvings on the exterior of that tomb. So similar to my previous work, I have, this is one of my major collaborators and studio manager, Kayla Quinlan. She's actually a model and shows up in all of my artwork. This will give you a sense of scale. So you can imagine the piece that I showed before. It was made by first making a 10-foot by 25-foot painting on translucent film. But now when you can kind of go look at careful detail, what I was doing is I was like, by way of Hale, looking at the carvings of what was on the facade of Mount Wilson of King Tut's tomb. Some of these details were actually taken from some of the early images that Hale was studying by looking at the surface of the sun. And this gives you like an overall sense of scale. I'm going to show you a quick minute and 30-second video of how these things are made for a different piece called the Black Sun Shadow Moon. So there you can kind of get a sense that each of the pieces is then sandwiched in between glass, rolled out in sun, and exposed in the sun. So in that sense, it's a photographic process, but there's no use of a camera or a darkroom. This was the largest piece that I made. It was made for the Getty's exhibit, Pacific Standard Time, Art and Science Collide. This was installed at Caltech in Crossing Over. And again, I was interested in thinking about the way that scale is such a major component of how we think about astronomy. And I wanted to include this dialogue between Henrietta Swan Leavitt and Mount Wilson Observatory. So there we have the Small Magellanic Cloud. And when we go back to this piece, then the M31 Andromeda. So this piece has a varying level of 8 levels of scale. And when I was in an undergrad, I was shown this video, The Powers of 10 by Charles and Ray Eames, which is, it's so beautiful. It's made in 1977, and it starts with someone sleeping on the bank of Lake Michigan, and then it goes up in the universe and then down into his hand. And one of the coolest things about Charles and Ray Eames, they were well-known architects. You probably either have you've seen plenty of their furniture, but they were really interested in creating artwork that were like somewhat didactic. And so this is like one of the screen tests for it, but when you look closely at this film, you can find it everywhere online, it actually goes back and forth between photographs and paintings, like gouache paintings or drawings, because there were certain things that they didn't have the technology for. And so I thought for my piece, I would figure out a way to, like, how we understand scale. And I invite you to think about this tonight, because you're gonna think, oh my gosh, the scale and size is something that is repeated. Number one, that road was so long, it is so high up here. This dome is so giant, that telescope. And then there's something so profound. You absolutely have seen images of the universe from the James Webb Telescope or Hubble that are going to be far more, say, stunning. But nothing is like seeing an object that becomes embodied, and you think about how it relates to you. And that's really my favorite part about the Powers of 10, is that scale is really just like a way that we experience and embody the world around us. And so I wanted to make sure to include that, and I have two small kids. Jasper, which is why Diane Ackerman gave me that poem. It was after one Jasper night. And this on the right is little Atlas Cannon, and he's named after Annie Jump Cannon. I wanted him to grow up and be like, I'm named after this badass astronomer, Annie Jump Cannon. And so they helped me in this piece lay out and become the references to scale. And I'll tell you that when people ask me about this piece, the one question I get is, how did you get a 3-year-old to stay still? And we tried it one weekend, and he was like wiggling about, but then I realized that his one true leader, who's Jasper on the left there, that if she told him to stay still, that he would do it. So he's laying down and she's above him going, if you want your donut, you're not gonna move. And he stayed, he stayed perfectly still. You can see every strand of his hair. He stayed perfectly still for 4.5 minutes. I'm going to end on one other project that will leap even further out in the scale of our universe. And we're going to kind of end where we started, which is this piece. So this piece, which was a painting of a wormhole, it's somewhat like diagrammatic. The way that I got to making this painting was that my mother had given me a book called Black Holes and Time Warps, Einstein's Outrageous Legacy. And it was a book by Kip Thorne. And Kip is, a very beloved scientist here at Caltech. And right when I got out of grad school, it was probably like 5 or 6 years after I got out of grad school, I was at a party for some Caltech scientists. And I overheard his name, and I rushed up to him with no chill whatsoever, and I said, oh my gosh, my thesis show had a painting that was influenced by your science and that book, and it just really made me understand the experience of what it would be like to move at the speed of light and what extreme gravity about black holes would be. Would you want to come over to my studio for a studio visit? And he said, well, there's this young filmmaker who's interested in making a film about my science, but I need someone who actually understands like the warping of time, so maybe you'd be interested in making some drawings with me. And I was like, of course, I would love to do that. And this was the first one that I did, and it was in my moleskin. And I ripped it out and I gave it to him, and he took it to Steven Spielberg. And that movie was Interstellar. And didn't work on that movie, but he was ended up, later Christopher Nolan ended up directing it. But Kip and I had started what turned out to be a really fantastic friendship. I made these portraits. I have never shown them before. But when we were working on our book, I said, for our publisher, our author photos should be, this is Kip and I. If we were 8 years old, we would have been best friends. They ended up going with photographs of us, but I think these are pretty cute. So we basically just started meeting, and Kip would tell me something weird, and I would make paintings of it. And I always like to think, like, Kip would tell me something bizarre, and it would sort of like make my head hot. I would say, like, is it sort of like this? And then he would write about it, and he was invited to do an article for Playboy magazine. This is a true story, guys. This is the start of every great collaboration. And he said, I'd love to, but I would like this young artist, Lia Halloran, to do the paintings. And I did all the paintings, and I was personally rejected by Hugh Hefner because I don't think I had exaggerated my women in the article enough. But what it did, was we took our kill fee and we started what we referred to as a little book for almost 10 years. But every time Kip and I would get together, we would meet every 2 weeks for over a decade. And the book it was first about black holes and wormholes and gravitational waves. And Kip's known for being the creator of the movie Interstellar, but he also founded the gravitational wave detector LIGO. So he won the Nobel Prize. Ray Weiss unfortunately passed away. Many of you probably heard about that a week and a half ago. There's a really beautiful New York Times piece. I highly recommend looking at it. It talks about the gravitational wave detector LIGO and how Ray and Kip collaborated, and Ray was the engineer for that project. But this was the product of it was 13 years of conversation, and the book is not so little anymore, 240 pages, and it features one space traveler, which is my wife, Felicia, and we wanted to make a book that was very different than any didactic book that kind of existed about science. And Kip, I love hearing him talk about it. He says, when he saw his words next to my paintings, he had an epiphany that it could be translated into poetry. And so the book is basically a 240-page poem about black holes, wormholes, time travel. And one of our first people who gave us input on it was Diane Ackerman. So she's also become really special to us in a lot of ways. So here's a couple of stills from it, and I'm going to show you a little 2-minute film that was made will show you animations from the book and a little bit about our collaboration. How did our universe begin? Can anything travel backward in time? How does warped space-time behave when wildly, frenziedly writhing like the open sea in a storm? Our universe is varied and vast. Galaxies, planets, stars and moons, quasars, pulsars and magnetars. Our universe is varied and vast. Our universe is also endowed with a marvelous shadowy side that is warped, phenomenon forged from warped space-time. How does the warped side of our universe impact the material side, the side that we humans see and feel? How do you even start to understand something that you know you're never going to be able to have close observation of?
As a scientist, I have a very geometric mind. I translate the mathematics into pictures. Those mental pictures help me make much more rapid progress.
I really bring the language of abstraction, figuration, representation to a distilled translation of Kip's complex ideas.
Science for me has had a very emotional side to it. And the idea of converting what was originally prose into verse was a totally unexpected epiphany.
What is Felicia? She's the sum of all her parts. Her heart,
her brain, her precious personality. And what is a black hole? It's the sum of all its parts. It's space that is warped, the funnel of bulk being seeds, its vortices of whirling space, its tendencies that stretch and squeeze, its slowing time and down cascading time, its horizon and its singularities, all made from warped space-time.
The warped side of our universe is home to many beasts, forged from warped space and time. Beasts that may well include black holes and wormholes, time machines and cosmic strings, gravity waves and singularities of our universe's Big Bang birth, and many other beasts, wondrous, weird, and wild.
So when Dan asked me to do this talk, it's a cool video, right? The first person I called was Kip, and I was like, are you free on September 13th? Because I planned on surprising him and inviting him to come and do poetry with me right now. And then he surprised me right back 2 weeks ago when his sister planned a family vacation with 7 of their siblings. So Kip sends his regrets. So you'll have to come find us reading poetry to you another time. We've had a couple of exhibits of this work. This was more recently at the National Academy of Sciences in Washington, D.C., some of the original pieces. But over that 13 years, I made 660 paintings, which I think just kind of goes to show like the back and forth iteration. It was made in such an unlikely way. You would imagine that it would be like Kip started with something that, like, whether that was prose or poetry and ideas, but it was very naturally an organic, like, exploration of just our conversations. I had to force him to make a chapter about winning the Nobel Prize. He was totally fine leaving that out. The last kind of thing I'm going to say of why this place is so special to me is that, so I'm a professor at Chapman University, and one of the reasons that I love Chapman so much is that it really celebrates interdisciplinarity. So the semester that I started, I went to the then provost, Daniele Strupa, and I said, I have this weird idea for this class, the intersection of art and science, and I have friends at JPL, and I think if we could like do something really unique. And he said, absolutely. So I've developed and taught a lot of different interdisciplinary courses, and my favorite one that Adam was in, the very first one, is called The Intersection of Art and Science, and every time we teach it, we rent out Mount Wilson's 60-inch dome, and truly one of the most, and watch the person that you came here with, and you'll maybe see this, but I get, it's so incredible the first time that you are able to observe through these telescopes. One of the like, my favorite thing that happened is like, we're all in line taking turns looking, and I turned around to one of my students and I said, I'm so excited to be in this class. And she said, Lia, you wrote this class. I was like, it actually feels like that. And I hope that you also have this experience as well. And I just want to end with a big shout out to my amazing studio crew, Adam and Kayla, who are here. You want to raise your hand? Because you guys are like, yes. Both Chapman students that I will not let go. But honestly, it's like they have been such an important part of collaboration for me, and I think that at this point, teaching is really a natural extension of my studio practice, and it reminds me so much of that early experience at the Exploratorium, where it's like things, figuring some of these things out is not like easy, and it's really exciting to have fantastic people to work with, and that is my that's my last slide there.